A trauma patient rolls through the ER doors. They are losing blood, and their pressure is dropping fast. The immediate mechanical fix is obvious: pump fresh volume into their veins. But doctors cannot simply grab the nearest IV bag off the shelf. If they inject an incompatible blood type, the treatment will trigger a rapid and fatal immune response. The patient's own immune system will flag the incoming red cells as hostile invaders. It will attack and destroy them on sight, causing the blood to clump and the kidneys to fail. The cure becomes a poison. In severe trauma, the clock prevents doctors from running extensive lab panels. Survival depends entirely on identifying a biological match in seconds. Think of the human bloodstream as a highly secure, exclusive environment. The immune system patrols this space, constantly checking the credentials of everything that flows past. Looking at this red blood cell, we see the first layer of compatibility, A and B antigens. They sit on the surface, acting as security passes. A second layer is the Rh factor. If present, the type is positive. If missing, it is negative. Your specific combination of A, B, and Rh forms a strict classification. That profile dictates exactly whose life you can save and who can save yours. To manage everyday surgeries and routine care, the medical supply chain relies heavily on the most common antigen combinations. A positive has the A antigen and the Rh factor. It is widely available, and hospitals use it constantly because these patients can safely receive both A and O blood types. Remove the Rh factor completely, and you get A negative. It is far less common, and its compatibility rules are much tighter. An A negative patient can only receive A negative or O negative blood. B positive carries the B antigen alongside the Rh factor. It shows up less frequently across the total global population, but it clusters heavily in specific regions, making it a highly utilized resource that accepts B and O types. On the other hand, B negative lacks the Rh factor entirely. This true rarity creates a persistent logistical challenge for supply managers, as individuals with this type can exclusively receive B negative or O negative. These standard types carry the bulk of global medical care, but their rigid compatibility limits create a fragile system, one where a sudden spike in local demand can drain a hospital's reserves overnight. The rules of antigen security are not evenly distributed. They produce two biological extremes. This diagram shows the first extreme, AB positive. Because these cells carry the A antigen, the B antigen, and the Rh factor, the immune system recognizes all incoming blood as friendly. They are universal recipients, able to accept any ABO or Rh blood type. Drop the Rh factor to make it AB negative, and that universal flexibility vanishes. It is one of the rarest types in existence, strictly limited to receiving blood from other negative types. Back in the ER, the patient is crashing. There is zero time to run a lab panel to check for A or B antigens. This is where type O steps in. O positive carries no A or B antigens, but keeps the Rh factor. It is the most common blood type worldwide and can be given to all positive blood types. Then there is O negative. It lacks A, B, and Rh entirely. Because the cell surface is completely bare, it slips past the immune system undetected. It is the universal donor. When doctors are flying blind to save a life, O negative is the immediate solution. It's the blind safety net that keeps emergency medicine functioning. But sometimes the standard biological rules of the ABO system break down entirely. This visual shows the Bombay blood group. In standard tests, it looks exactly like type O. However, it completely lacks a foundational building block called the H antigen. Without this anchor, pumping standard O-negative blood into a Bombay patient triggers a fatal immune response. Doctors are forced into a frantic global hunt to locate one of the few other living Bombay donors. Then there is Rh null, known as golden blood. It lacks absolutely every single antigen in the entire Rh system. It is the rarest blood type on the planet. For the dozens of individuals with these extreme anomalies, survival relies on a terrifying global lottery, dependent on a handful of specific living donors scattered across the world. In the trauma bay, the patient stabilizes. The surgical team executed their procedure, but the patient only survives because the exact correct blood type was immediately available. That resource cannot be manufactured in a lab. It only exists on the IV pole because someone else chose to sit in a chair and give it. The entire medical infrastructure depends on a constant, fresh influx of matching biological profiles. Learn your own type and ensure it is available in the system. Regardless of rarity, your specific blood type is a physical necessity for another person's survival. When the system works, it is because a donor provided the one thing medicine cannot create.